All right, we're ready to go. Helmut?
Thank you very much, Jens. My name is Helmut Hlavacs. I'm professor for computer science at the University of Vienna. And as Jens already introduced, I will talk about how we use C++ in teaching at the University of Vienna. And I will talk about how we teach the programming language itself and how I make use of it in all the theses and that are created by the students and how I mentor them and what kind of topics we do. I come from the University of Vienna, Faculty of Computer Science, and I had a research group called Education, Didactics, and Entertainment Computing. In short, Eden, and my part is the entertainment computing part. So I focus on entertainment computing, a couple of stats about the university itself and computer science. Our university is quite old, was founded in 1965. We have roughly 11,000 staff, 87,000 students. We're a top 100 university. And we teach computer science in bachelor and master programs, bachelor lasting 3 years, master 2 years. And of course, in the bachelor, especially, we have introductory courses on programming. I will talk about them shortly. And mainly, they really revolve about C++. So there's a big chunk on C++. It's not only theory of programming, algorithms, how to represent data and all those things, but then you really get into learning C++ as deeply as possible, but also then contrasting it, for instance, with Java, which is, of course, as we know, very similar. But the other big chunk that can be used for teaching C++ and other languages, of course, is when students actually work on their thesis. And in the bachelor program, at the very end of the study, students are supposed to create a thesis. And for the bachelor's program, they have about 1 semester, and the size should be about 25 to 30 pages. So it's rather a smaller thing. You can do it in 1 semester, but it still should be, of course, have good quality. And in the master's program, we have at the end of the master's program, we have a couple of lectures on just focusing on creating the thesis. And there, the thesis should be much larger. So it should be really substantial. You should devote a lot of time on this, implement a lot of stuff, and also have substantial scientific results, actually. Now, when we teach C++ at the bachelor level, we have 2 lectures consecutively, each of them having 6 ECTS. Usually, we have roughly between 200 and 350 students, depending on if it's in summer or winter. So that's a lot of students that we have to teach. So we have one frontal lecture where we just present the material. I'm not involved in this. I'm just telling what my colleagues are actually doing. And besides the lecture, there is then this practical course where students are supposed to create programming in much smaller groups, of course, so they can be mentored accordingly. And of course, they would learn in these programming classes the usual stuff. Of course, in programming 1, they would learn all the basics, the loops and classes, and even templates, as far as I've understood. And so really the basic stuff of C++, whereas in programming 2, of course, then they go much deeper, and then you get to stuff like smart pointers and SDL containers and algorithms, all the stuff that makes your life easier and that you need to know, actually. Now, teaching C++, as you can imagine, to students who have never heard of that is hard and is very difficult. And we see actually that students struggle with that. So we cannot say that after the lectures, they are actually perfect programmers. Some are, but they are more the exception, as far as I've heard from my colleagues. I asked them. But mostly we see that they struggle a lot in order to not only grasp the theory, but then, of course, implement the theory in practical programs. And so for that, I think that the time that the students have is much too short. So for grasping all of these concepts, you need actually years to focus on that. So it's a bit overwhelming. And my colleagues told me that they're kind of reworking now and kind of simplifying stuff, taking complexity out, so that what you actually see and learn can actually be contained in your brain, so you can take it in and really understand stuff. So simplify. So I think that's one of the big lessons. Here are a couple of teaching sources that we use. I think they're not surprising. Of course, Scott Myers is a staple. Professor Strostrup, of course, Herb Sutter. These are the big names and their books, and of course we use them for teaching C++. And my students, they know more or less better than I do when they went through the bachelor what is actually happening in these lectures. Now my part is actually much later when the study ends, and they are now doing a thesis, and they want to work on a specific topic, and so they come to me, and then I have a big list of topics. You can actually see them online, so it's just follow this URL, and you can see all the topics currently available. And for me, a topic must be really interesting. It should be a unique idea. You should try to solve a real problem. So when you go through the world and you think about what's not working, of course, as a computer scientist, you try to find a solution with a computer in order to improve the situation. And of course, I really want to have theses that contain extensive implementation parts. So it's not just writing text. It's really you have to implement something. And that should be a substantial work. It should be hundreds or thousands of lines of code that actually works and that solves this problem. You can show it. You should know your theory, and you should be able to implement the theory in practice. And once you have all of this, the time you do that, I think you get more into the details of C++ and learn how to make best use of the language. There are a couple of formal requirements, and maybe much more. I really, my big wish is when it comes out, when it's finished, it should be of such a quality that you can actually publish it at a conference. It could be a peer-reviewed scientific conference, or in a forum like this, Meeting C++, for instance, or CPPCom or something like that, like an industry conference. We published a lot of talks at Vulcanized, for instance, in the last years. So I really want to have a very, very good quality, and my students know that I will not stop until the thesis really looks perfect. Of course, it must be a scientific work. You should have proper research questions, hypotheses, and carry out experiments, come up with good statistical induction in order to prove that. And here are a couple of topics that I'm focusing on because it's entertainment computing. It's more focused on games, gaming technologies. Some students are more in the design. They might create a game, for instance, a serious game. But more and more, we have students who are actually focusing on the very technical things, on game engine technologies, on the Vulkan API, Slang shader language, making use of GPUs and so on. And currently, I'm actually mentoring about 50 theses, so that's a lot. And so it takes a lot of time that I gladly invest in order to have a good quality output. Now, as a teaching resource, I actually started the Vienna projects on my GitHub. If you go there, you can find a couple of repositories there. And what I did was I tried to implement myself a lot of stuff like a physics engine, a Vulkan game engine, coroutines based job systems, and so on, a type list library for C++, in order to also to be sure that I understand what's going on, how these things work. And all of these projects that you can see actually are C++. So this is pure C++. And I try to implement them first myself, and then of course students might take over, might change it. Some of these projects have been initiated by students. I wasn't really involved in that, but mostly I am. So this is a very important resource for teaching. Already you have a lot of C++ code that hopefully works, that is well structured, simple. It should not be too complex in order to be able to understand what's going on. And convey an interesting idea in the entertainment computing world but still it should be C++. A lot, and most of the time it is. So here you see the Vienna physics engine and how I simulate all of these objects. And one of the talks today will actually be around the geometry and collision library that takes out a part of that and tries to implement it in a good way, because when I implemented it, it was probably not that good implemented. It just worked. So that was the mess thing. And now it's time to actually make it in good and well-structured code. I do this currently. So this is my side project I'm currently working on. This is my AI loop. Whoever's interested, drop me a line. This is simply a tool where you have a controller and a worker. And currently you see it's because it's now, this is a snapshot from an hour ago. It's working on the physics engine. It's trying to restructure the physics engine. And you have a controller and a worker. Usually I use Opus as a controller and Codex as a worker, but I ran out of tokens. So this really is eating up my tokens. And this is really working on my C++ repo and restructuring the code. And the controller makes the plan and the worker carries out, and they are connected with a database and with a message queue. And so it goes round and round, and gradually they are eating up all the tokens. So here we have already to date, we had 550 tasks that was sent to the worker and then coming back. So this is a tool that I also want to, at some place, when it is really, really polished and so on, I want to give to my students. And finally, a couple of links. If you're interested, we have my homepage and the topics that I was talking about. Lots of thesis topics that my students are working on. We have showcases where you can see past thesis and some video, maybe an occasional video. But you mainly see the finished thesis. Okay, so you can download the bachelor and master thesis. And here we have a couple of presentations. Most notably, in the last years, we had a couple of presentations at the Vulcanize conference, which is an industry conference about the Vulkan API. It's a C API, but there is a C++ binding that I will introduce in the teaching in the future. And of course, as Jens mentioned, we had a talk at Meeting C++ with two of my students, and these were actually bachelor theses. So they worked on a specific part of my game job system and make it parallel and make it debuggable and things like that. So very, very nice work, pure C++. And we had a really nice experience in going to Meeting C++ in 2025. It was a huge event and really, really interesting. Yeah, and finally, I had also a talk at CPPCon 2021 about that. Yeah, if you're interested in any of these projects or just watch them, download them, drop me a line, whatever. Yeah, that's it. Thank you.